Welcome to Use What You've Got. I'm Sarah Simpers. I'm a senior technical writer at MongoDB, and I work on the Cloud Docs team. So I document MongoDB's cloud-based products, such as Atlas, which is our hosted database service, and its command line interface, the Atlas CLI. Improving the developer experience through better docs has always been important to me. But about a year ago, one of our product managers said something in passing in a meeting. And once he said it, I could not stop thinking about it. Here's what he said. He said, maybe the commands in the docs could automatically update themselves. Maybe the commands in the docs could automatically update themselves. The reason he said this is that the CLI puts out a lot of releases. So code snippets that contain CLI commands are a constantly moving target. They get outdated very quickly. And having outdated commands all over the documentation does not make for a good developer experience. We didn't have anything like that in our Atlas docs at the time, but I became determined to make it happen. I tried various things. I wrote a janky Python script that did not work. And then, finally, I did find a way to make it work. I found a tool that could leverage the existing code to add auto-updating Atlas CLI commands everywhere in the Atlas docs. That is. But that's not the end of this story. It's actually just the beginning, because once I made that update, I moved on to the next improvement for the Atlas CLI and its docs, and the next improvement, and the next improvement. And now, after a year of incremental updates, I'm here today to tell you a valuable lesson that I learned during this process. Here's the lesson. You can improve your developer experience using code you already have. If you remember nothing else from this talk today, I hope that you'll remember what's written on this slide. You can improve your developer experience using code you already have. Now, code reuse is not a new idea, but I want you to think about it incrementally. And I want you to think about it in terms of docs. So small, digestible changes that you can make in your docs with existing code that is not going to require you to reorganize your entire quarterly plan, but may have a bigger impact than you might imagine. And when I say improve developer experience, I mean internal developers and external developers. I wanted both to have a better experience when using and contributing to the Atlas CLI and its docs. So today, I'm going to explain how I improved the developer experience through docs at MongoDB as a technical writer, and maybe convince you to try it too. So let's talk about why you should make things better for developers. What's in it for you when you improve the developer experience? First benefit, you make it easy for external developers to start using your product and keep using your product. You do this so that they don't hate using your product. And I think we've all used a product before that was either so difficult to use or so poorly documented that we stopped using it altogether. Or if our organization made us use it, we used it begrudgingly. Don't be that product. Make things easy for external developers, and they will love you and your product. Next benefit, internal developers can easily add to the docs. We auto-generate our command reference from the CLI code itself. So every little piece of existing code can be leveraged for the docs. It means that internal developers, when they make changes in the code as they normally would to add to the CLI, they can add to the docs without increasing their workload. It's a win for external developers. It's a win for internal developers. And finally, more contributors and faster results. By using the code that your internal developers already wrote, you can lower the barrier for entry for other stakeholders to help make your product great. Stakeholders like technical writers. As a writer, I can leverage existing code to make improvements. And results also go to production faster when you use existing code. I didn't make all of the improvements in this presentation at once. I made them incrementally. And every change made life a little easier for our developers. All right. So if you want some hard evidence that those results actually, or those benefits actually exist, here are the results that we saw at MongoDB. First result, this is the big one. We saw a huge increase in monthly active users of the CLI itself, not of the docs, after a docs change. 69% increase in monthly active users of the CLI. Is that incredible? That's after a docs change. If that doesn't convince you that improving developer experience means more people will use your product, I don't know what will. The next one, kind of similar. 61% more organizations created with the CLI following that same docs change. Now, these two numbers together tell us something important. Not only were more people starting to use the CLI, so creating orgs is generally something you do when you're just starting out, they also keep using the CLI because monthly active users is a measurement of use over time. So they start using your product, they keep using your product. The next one I think is pretty neat. 20,000 additions in the CLI code repo were made by technical writers. That means that stakeholders outside of the core developer group are making a significant contribution to the CLI code repo. And that takes work off the plates of internal developers. Those are 20,000 changes that they don't have to make. So with these numbers, we show that we're making everyone happy. External developers, internal developers, and technical writers. Wins all around. All right, so enough about results. Let's talk about the actual updates. What did I change? I made 3 incremental updates over the course of about a year. The first one was to add Atlas CLI commands everywhere. I wanted everybody to know about the CLI and find it easily. The second one was give the output for commands. And the third one was state required roles for each CLI command. Today, we're going to explore how I made these changes in the code and talk about why they improve the developer experience. But before I go into that, I wanted to quickly go over our CLI stack. So I want to give you some context for the code changes that I'm about to show you. Our CLI stack starts with the Atlas Administration API. It's the API for MongoDB Atlas, and that's where all of the data is pulled from. Then we have 2 GitHub code repos. One's called MongoDB Atlas CLI, and one's called Cobra to Snooty. Together, these do a few things. They pull data from the API. They use the Cobra open source framework to build the CLI itself, and also to generate the docs. So we generate our docs in that code repo, MongoDB Atlas CLI. And then Cobra to Snooty transforms those docs into RST, or restructured text, which is the language that we use for our documentation, because we do docs as code at MongoDB. So our docs also live in a GitHub repo. And then finally, there's DocCurl, which is an awesome tool developed by a MongoDB employee named Nathan Linez. DocCurl fetches the code files from the MongoDB Atlas CLI repo and drops them into the docs repo at the latest release tag. That part's critical because it means that the files are always up to date with the latest changes that the internal developers have made in the MongoDB Atlas CLI repo. Also, DocCurl, which may be pronounced DocURL, it's up for debate how you pronounce that, is available for anyone to use. And it can be used for both public and private repos using GitHub access tokens. So if you think you might be interested, if you like what you see in my presentation, you should check out DocCurl. There's a link to it from this slide. All right, so let's talk about the first change. Atlas CLI everywhere. What is this change? How and why did I make it? The Atlas CLI docs are separate from the Atlas docs. So the intention here was that if a CLI command exists to do a thing, that we should put that command in the Atlas docs where we talk about doing the thing with the UI. So if a command exists to create a cluster, we should put that command in the Atlas docs where we already talk about creating clusters using the UI. Make things easy for external developers. Don't make them go looking for Atlas CLI commands when they're already on the page in the Atlas docs for creating clusters. But there is a flaw in this plan. And the flaw is that if you add more than 200 Atlas CLI commands to the Atlas docs, and they're static commands, they're not connected in any way to the source code, they become stale and outdated very quickly when the CLI puts out new releases and the commands change. So this project puts Atlas CLI commands everywhere in the Atlas docs, but uses DocCurl to pull in updated versions of the commands at every release so that they stay fresh and they're always giving the right commands. Because wrong commands are not much better than no commands at all. So let's talk about how I made this change. I used the existing code that was in the CLI code repo. That's what you see on the left side of the slide. It contains, there's one of these files for each command, and it contains the code block that has the command itself in it. In this case, it's Atlas access list. So I pull over the commands into the Atlas docs using DocCurl, which means I can add all 200 commands that look like the left side of the slide and just drop them all into the Atlas repo. And then I added the source code on the right side. So I added this intro text saying to do a thing using the Atlas CLI, run the following command. Then the literal include just takes the command itself, it trims out all of the text that comes before the command and all of the text that comes after the command, just isolates that one little piece that is the command itself, and returns it in a code block because literal includes are always displayed as a code block in RST. And I used these bracketed replacement values for task and command because this way we define this template with the intro text and the surrounding text in just one file, but then we can build on top of it with YAML extract files. So we can just define task command for all 200 commands, and it will slot them into the replacement places in this template and render the value for the place where we put it in the docs. So the initial work here was setting up DocCurl, pulling in all of the files and setting up this template and then defining the task and command for all 200 plus commands. So that's what the work looked like for me. What does this mean for our internal developers going forward? Because they're adding new commands all the time. Does this add work to their plate? Well, the dev work for this change is none. DocCurl updates everything automatically. This happens when technical writers run DocCurl in the command line, but we could further automate this so that it ran automatically if we chose to. So let me show you what this looks like in the command line. If I'm in the Cloud Docs repo, which is the repository for the Atlas docs, and I run DocCurl update, it tells me some versions are out of date. It tells me what's out of date, the MongoDB Atlas CLI repo. It tells me it's going to update that repo to version 1.6.0, which is the release tag for the latest Atlas CLI release. And then it tells me it's updated to 1.6.0. So now it is up to the most recent release for the Atlas CLI. Then I run DocCurl fetch, and it says fetch 250 files. So it just grabbed all 250 auto-generated command reference files at the 1.6.0 release tag and dropped them into the Cloud Docs repo. Then from there, that literal include I show you takes over. That pulls them into the actual docs pages and renders the result. And here's what that looks like. At every Atlas CLI release, DocCurl updates 200 plus code snippets in the Atlas docs automatically. So the gray code blocks that you see on the screenshot are the parts that are getting updated at every single release. The text that surrounds it is what's defined in the template, and that can be changed in just one file. This setup really came in handy recently because the CLI developers made some pretty big changes to a bunch of the commands. If we had had to make those changes manually in the docs, it would have been a lot of work. Instead, we just ran DocCurl update, DocCurl fetch, publish the docs. That's it. Everything is up to date. So this change is a win for external developers because the commands are highly visible in the Atlas docs. You can actually see here that the Atlas CLI tab is the default tab that displays, even before the Atlas UI tab. And they can just switch between the two easily with that toggle button. Internal developers benefit from this because there's no extra work for them at all. These are just the commands they were already going to define for the CLI itself. And technical writers benefit from this because they are defining this template in one file. So if we decide across all 200 instances where we have Atlas CLI commands in the Atlas docs that we want to change the intro text slightly, we can just change it in the template. It's very easy to do. And also, it just is great that we don't have to manually update 200 commands across the docs whenever they change. So everybody is happy with this change. All right, let's talk about the second update I made. Give the output. What does this change? How and why did I make it? When I started this, we didn't show outputs in the command reference. And the reason we didn't show outputs in the command reference was that, similar to the problem with CLI commands in the docs, if you put a bunch of outputs that are static values into the command reference and then the code changes, they become out of date and they're incorrect. So we wanted to make sure that if we're adding outputs, that we can make sure that they update themselves. Because outputs are valuable for external developers. They make scripting easier because you can program the expected result. And they also just make it easier if you are in the terminal running CLI commands. Knowing what success looks like helps you know whether the command that you ran succeeded. So the setup for this was to reuse the variable that the CLI developers were already defining to show up in the CLI itself for an output to show in the docs as well. That means that when the developers go in to make a change to what the output looks like in the CLI, they also make the change in the docs at the same time with the same change. Here's how that works. The left side of this slide has what it would look like for an individual command reference docs file. So it would have the variable, in this case, it's create temple, that is the output variable. So this was already defined in the CLI code. And in this case, it displays the text deploying cluster name. What I did is I added the annotation that you see on the lower left to all of these command files. So I added output is create temple, or whatever the name of the variable is in that individual file. It differs from file to file. Basically, just call the variable that they had already defined as a new annotation for output. Then I made the changes on the right. These changes happened in the Cobra Snooty repo, which is the repo where we transform the Cobra fields into RST. So I pulled in the output where you see annotations output. I made some changes to how the symbols display. I wanted to get rid of those curly brackets and the dot that come before name, things like that. I added an output header. I added some intro text saying if the command succeeds, you'll see something similar to the following. And then there's a code block with the output itself. So the right side of this was defined in just the template. The left side is defined in every single commands file. That was the initial work that was involved in this. Let's talk about ongoing dev work. Developers will define the template or the variable for the output the same as they always would. They would have already done that to have the output defined for the CLI. But they're also going to add this little piece of code, annotations, output, and then list the name of the variable that they chose for the output in the CLI. So this does add work for them, but it's a quick copy and paste. It's not a heavy lift for them, and it makes it easy for them to contribute to the docs. And here's what that change looks like rendered in our documentation. We reuse the variable for the output in the CLI to show the output in the CLI docs. So that output section is what's new. It has an output header, it has a line of intro text, and then it has the text for the variable itself, in this case, deploying cluster name. This is great for external developers because they can see what success looks like. They can script more easily. Internal developers can use the text that they were already defining and leverage it to add to the docs easily. And technical writers can get involved in the nitty-gritty of the Go code here, which plenty of technical writers have that experience already, but a lot of them also don't, especially newer writers. So this gives them an opportunity to work in the CLI code and work in Go to make these changes. So again, all three groups coming out on top. All right, let's talk about the last change. The last change I'm going to talk about today anyway. State required roles. What was this change? We wanted to indicate the permissions to do a thing on every command's docs. So we don't have a situation where an external developer runs a command and it doesn't work. And they're like, well, why didn't it work? If the reason it didn't work was that they don't have permission to run that command, we should tell them that up front. We should tell them the roles that are allowed to run each command. So I wanted to do this similar to how I set up other ones. I wanted to have a template that has the surrounding text just defined once. That makes it easy to update it on an ongoing basis. And then define the actual role required for each command in the commands file itself. And critically, also wanted this to show up in the CLI itself. So not just in the docs, but if you're running a command and you use the help flag, I wanted to tell you what role you need to run the command. This makes it easier for people who are using the CLI but may not be looking at the docs file at that moment. So here's how I made that change. I found the usage.go file in the CLI code repo, which is the change that you see on the left. The usage.go file is where they define the text for all of their flags. So the descriptions for all of the flags that show up in the docs and in the CLI code itself. So I defined this new variable, required role, and this is the template text. To use this command, you must authenticate with a user that has the blank role. That %s is the placeholder for the actual role. So I made that change in one place. That's our template. Then on the right, I added required roles from the spec. So this change was made in each of the commands files across the 200 or so commands. So I added to the long text field, which the long text field is a standard Cobra field that shows up in the CLI itself, and also in our case shows up in our docs. I added usage.required role And I added, in this case, organization member, but this would be whatever the text is that should display in that placeholder value. So whatever the role is that's required for this command. I did the work on the right across all of the command files, work on the left just once. Now, on an ongoing basis, internal developers, as they add new commands, they can just make the same change where they add to the long field. They add usage.required role, and then they add the actual role that's required to run the command. Now, I'll admit that this could be more streamlined. We could pull from the Open API spec, which defines all the roles that are required, or we could just pull from the Atlas code itself, perhaps. But again, this isn't a heavy lift for internal developers to do this change, and it adds a lot of value for external developers. Plus, it gives me something to work on later because I'm making changes incrementally. And here you have the result. The Atlas CLI docs tell you the required roles for every command using consistent language. So the line that comes after telling you what the command does is this new change. To use this command, you must authenticate with the organization member role. And that will show up not just in the docs as you see here, but when you run Atlas access list -- help in the Atlas CLI, you'll see that same text. So external developers know what permissions they need. Internal developers can add to the docs with a small change, and technical writers can fine-tune the template surrounding text just in the usage.go file, and they also get that hands-on experience working in the Go code. And those are the 3 updates that I made. So as we discussed, these make external developers happy, internal developers happy, and technical writers happy. Everyone is happy. That's all I have for you today. I hope that the examples of the changes we made at MongoDB have been helpful for you. But more than anything, I hope that this starts your story where you start improving your developer experience using code that you already have. Thank you for your time.